Okay, hello. This video is about making a DAC curve for 70-degree angle probe. A quick explanation what it is our standards 17640 says that the first technique is the reference is a distance amplitude curve DAC for side drilled holes of diameter 3 millimeters. And there is also second, third, fourth techniques, so we are using the first one. It's also referenced in standard 11666 or fifth part technique 1 based on 3 millimeter diameter side drilled holes. So 3 millimeter side drilled holes is a DAC block like this. Well, you can, I have some drawings for myself. They look like this with some numbers, so I know where should I find at what depth the holes or something like this. And what I have done with this DAC block, maybe I'll switch to 2 videos down on the table. Maybe it will fit better. My stand is not this great, so what I have done is taped the block, and then here I marked the angles. So to get this hole, it's 3 millimeter hole. Here is the 45, 60, 70. Then here 45, 60, 70. So I know approximately that when I'm trying to get this hole with an angle probe of 70 degrees, I should put it like here, and then this hole like here, and then this hole like here. Okay, so it's easier and faster to do. Okay, so yeah, that's the block. If you haven't done anything with the machine from the last, I cannot fit it in, from the last video, then the settings are still set here, but let's go into the big menu, files here, so I can find the file name of the 70-degree probe and the recall dataset. Press enter, and here the file is loaded. So this is how you take the old settings and put it on the machine, activate it on the machine. Now what I will want to do is record these holes, and whatever I have found strange is here. When I load the settings and I go to the main menu, out of here I cannot return with this button, but then what I need to do is hold in the middle, and here it's frozen. So I click this button, it unfreezes, and then I go into the big menu, I go back and forth and can return easily, but And if I go back and I hold this, okay, it still returns. So we can go in and out of the big menu holding the middle button. Okay. Now I need to check the DAC TCG, and also I want to record it. So I'll be using the gate. Record 0 points, finish. Okay, let's start doing it. I'll get the DAC block, I'll take gel, I'll put it on here, I'll take the probe, it's working, not so great, but it's not this way, it's this way, and here will be this block. So it's shown in here and it's shown in here. So what I want to do is find the first hole. The first hole, because my place of the beam is 12 and my mark is like here, I need to find it somewhere here. And here on the screen I can see that there is a big spike. Let's try to get it with a gate. Okay, now up. Okay, too much, but there is okay. Gate start. So now I put no enter, back, up, left, here you go. Now I need maybe auto 80. No, like this. No, it's a messed up navigation, or I have no clue how to navigate it. Come on. Now going back. The gate is on. Now I need to go down then. Okay, now I need to go left. Good enough. Down. And how to switch auto 80 right? Well, it doesn't work. Record. Okay. Now I will move this by hand, the gain down, and do it manually and not try to find something. Okay, here is the button, so I'll try to, okay, now it made 80. Okay. What I'm doing now is I want to check the numbers here. This one, and this one. So what I'll do is take the ruler. Well, you should not do like that half an hour of DAC curve creation. Yeah, I'm just explaining it for the first time. I think the next time with a 60 I won't do that again. So the depth is 4. Now according to my pages it's 5, yeah, but it's 3 millimeters hole, so it's from here, it's a 4.81, so it's from 4.5, from 4.8 to something 5.7, something like that. So okay, 3 is maybe 2. It's not that great. Okay, 3, 5, 4. It's somewhere here. You should be doing that faster than this. 3, it shows 3. 3 is not great. Okay, let's check another one. The second one should be somewhere here. Okay, so it will be somewhere here, the second one. Let's do that and check the results then. How you do it is you just find here your hole like this, then you hold, come on, then you go down, record, and maybe to the, I need to make it 80, so I'm pushing this button. Okay, I need to record the point. Here, 1 point record. Now I need to go down now, not down, but find another one. Now what I need to do is move the gate. Like this. And when I find the second one somewhere here, the peak of the second one, maybe I can do it with the plus 80, I'll check. Okay, let it be this way. Hey, come on. Auto 80 does here maybe. Okay, here you go. And now I want to record it to the right. Here. What it did is, I'll explain later. Let's go to the another point. Now the third one is somewhere here. Somewhere here, the third one. So I'll just do it like this. Now I may need to move the gate like this, auto 80 like this. Then if it's good enough, I just record this. One more. The last one goes from somewhere here. Here you go. Move the gate. Now the gate is big and the spikes are not. Okay, I just need not to take the second one, so this will be good enough. Now I just need to find the peak of this hole, then I will do auto 80 and then I will record that. Can I get that's the 4 points. Now can I get one more from here to here. I need the ruler, but that can be like 45 and 60, so maybe 70 will be somewhere here. So let's finish with 4 points. Okay, so now what I will do is go with these number buttons down so you can see the graph of the 4 points that is drawn here. That's not great because this, if it's like about 80, that should be like about 20. So not a great graph, but something like that. But when you work on the piece that you are testing and it's very small there, you cannot see well. So that's the problem with such a graph, such a line, because here when you find this one, okay, here it's good enough, but when you go down and find this one, okay, it's smaller, and here you already cannot see clearly this small, so that's not good. Okay, that's not good, but what to do? I'll check, maybe I'll write one more video about it. Now, what you do with a DAC curve afterward is, according to the standard, it's easier to work when you have several lines. The one line that is here, we call it reference line or level. I'm taking it from standard ISO 11666 part 5, it's reference line. Now, that's A, then there is B, C, and D. D is evaluation level, okay, and C is recording level, and then B is acceptance level. Now I will try to explain what it is in simple terms, but you should consult ISO standard for many things about these graphs. So we have a reference line that is on the screen. The evaluation line that we are checking the spikes from is minus 14 decibels. What it means is when in the screen my spikes that I found something goes here, that's the starting point that I need to check this thing in more details, okay, and try to figure out with the different angles what it is, okay. Now when it goes like up there, this spike, and there, and then it goes like this, here is the end of the defect. When it crosses the evaluation line and when it starts and ends, here is the peak decibels. These are important things, okay. So when you start, if you find something over the evaluation line, you have to check it in more details. Now, according to the standard, and this is thickness, this thickness, acceptance level 2, So these lines are drawn. The acceptance level is -4 and the recording level is -8 and the evaluation level is -14. So I'll do it on the graph, but these changes with the acceptance level 2 or 3, with the thickness and with all kinds of things. So if you find a defect, you have to check according to the standard and according to the acceptance level that you're working with. I will read one more sentence from the standard. Determination of discontinuous length, the length of the defect. Okay, the length of the discontinuity shall be determined by measuring the distance along the length over which the echo amplitude is above the evaluation level, using the fixed amplitude level technique specified in Annex B. So when the graph goes over this level, we determine where it starts and where it ends, the defect. That's 11666, part 4. Now, how to draw 4 lines here. I'm going to the big menu. Here is the DAC TCG menu part. What I have here is DAC TCG DAC mode, and I want to put it on. Somehow it doesn't work. Okay. It doesn't work at all now. What? Okay, how to... I have to finish maybe recording. Okay, click here. Okay, go up. Go up. Go stored. Okay, here. It was recording still, so when you record all the points of the DAC curve, you have to finish it. And then you will see something like that. Now, let's go and look at this menu. DAC mode is on. TCG display no. Later. DAC type, you can make it straight or curved. Let's make it with the corners. And here, if you want to delete what you have done, you can do that here and it's gone. Let's go back. Come on. Now let's go back. Okay, now I'm going to this DAC TCG, then I'm pushing up and I'm going inside the bigger menu of DAC TCG. What I have here, TCG DAC straight stored. Okay, edit. I can edit points if I don't like them. Offset. Now, here are the lines. I am going up and I have how many? 4. Okay. With this 4, the first one we have will be -4, then -8, then we need like 3. Okay, 3, not 4. So I am making the first one -4, that's good enough. Then this one is going to be -8 decibels. here is the line of the recording. If you find a defect over the recording line but under the acceptance level, you should put it into the report. That's according to the standard. Then the third one is -14. That's the line that we are going to check the length of the defect that we found. It should be -14. Here you go. And this one we should delete it or maybe make it 0 so it doesn't show. Maybe let's try putting it 0 so it will be easier for us to figure out. We won't see that. Oh, okay, good. So here, now we have a graph and we have 4 lines. The one evaluation, recording, acceptance. This line is important because when your defect goes over it, well, it's not acceptable already. But it depends on the length of all kinds of things according to the standard. And if it goes through that, that's you need to cut that. Okay, so what else? Offsets 2, then going down, and that's it. Going back to work. I want to go, how do you return back? Okay, I'll return back with this middle here. Now, let's use the, okay, if you cannot see this. So if you increase the gain, it's frozen. I need to unfreeze it. Now, when you increase the gain, you start seeing this thing here. Okay? So, yeah, it's difficult to work with such a graph. Okay, and when you take this DAC curve and you take, let's say, the third hole from here with a 70, the third one should be like here, so you can check if it goes here. Yeah, you should not like push it ideally, because you should be doing it like near the working condition, so not like exactly the maximum amplitude, because I can go over it if I want. I can find a spot of this hole like this that it goes over, but well, here. So I don't think you need to, you should use that as the working conditions. You won't just be doing the testing for 2 hours, 1 centimeter. Now, so do that close to working conditions. Now, here is the third point. Yeah, and I need to move the gate over it. The gate is moved. Okay, let's do it like that, but I think there is an easier way somehow. So let's go to start, let's move it. Then I think we need to change the color and things with that. Okay, now threshold. Okay, here. What it shows to us that the decibels are 0.5. So in the report, when you have a defect, you write like decibels plus 0.5. It's high, it's not under. But now let's look where it starts. Okay, so the length, according to this method of testing, can be something like, it can we should cut from here, let's say, yeah, because it's crossing the evaluation line here. So something like here is the start. Well, no. The idea is like this. When it starts crossing it, it's the beginning. Then it's going up, it's the maximum amplitude here, and then it's going down. So it's something like here it's finishing. Maybe here, okay? So when you have this, you just have to mark it, and you see where it starts and where it ends. And it's the depth, I think. Okay, so well, I'm a bit tired already. Let's check the first holes. So it's over here, it's high. So here this spike goes from here, then it starts going up, down there, then it moves, disappears. Okay, so here is the end, here is the maximum, here is the start. The idea is like that. Okay, now I cannot see where it goes, and the gate is not on it, so I don't know the decibel. So what I have to do is make the graph smaller, the gain. Okay, here it and my first line is the reference line, and then I'm going to find another one. There I found it. So it goes up, here is the start, then it goes up the maximum, and then it disappears. Okay, so here I'm going to decrease the size of it, and then we can see here, yeah, I can find a spot where it gets higher than this line, but it's not like too high, and it will be like plus 0.2 or something if I move the gate there. When you find the defect, you need to move the gate, because then you know all these numbers. Now it doesn't show, but let's try to move the gate. Okay, in the middle, and then no. How do you move the gate? There are some. Come on. No, it doesn't move. Edit or action blocked while frozen. Okay, I have frozen something. Here, unfrozen. Okay, it doesn't work like that. I need to check how to move the gate. Okay, here is the gate. Start. So just move it, and maybe with this one. Okay, with the function key here. And then you see that this amplitude is plus 0.5, and then here is the start, here is the maximum, here is the end, and so you have found the defect. And what it shows is the depth of it, and what else does it show? Okay, the distance 6 millimeters and 17. So if I take the ruler from the beginning of the probe to the hole, there should be something like 6 millimeters now. So if I measure it somehow, well, it's something like from the corner of the hole. No, the hole doesn't have the corner, the side of the hole. Yeah, it's 5. If I take, let's say, the upper side, then yeah, it can be 6. If my probe goes, sound goes like here, not like here, because the angle is 70, so it should reflect from somewhere here, and this part is like 6. Okay, so here is the first one, here is the second one, here is the third one, and then you see that we have a problem, so you have just to increase it. Okay, now I understand that I need to talk about TCG. What is DAC TCG? What is TCG graph? TCG graph does this. When we have a DAC curve, because the holes are deeper, our graph looks like this. The first one, the second one, the third one, and then the fourth one. You cannot see. Okay? And then there are more lines. What TCG does is puts this view into, recalculates it and makes it fit your screen. So it makes it like this. Okay? And here is your reference line. Here is -4, -8, -4, -8, and -14. Okay? This is the idea of DAC into TCG. How does it look like? What it looks like? Okay, here we go to the DAC TCG. I think we go down. No, we go up. Here is a bigger menu. Now we go where? Back, home, DAC TCG, up, no, here, setup, up, and here is TCG mode, and right, off, and then TCG. What it does is makes this graph. Now, maybe for demonstration purpose that will be fine, but I don't think it will look very beautiful. Okay, let's put it there so you can see. For work purposes, you should make it better than I did here. Okay, so here, when I find the first point, we found it here or here. Now it shows here and it goes up to this line, the reference line. Okay, now what I am going here is all kinds of, it increases these spikes, but it also increases the noise. So when I'm going to the left, here is another point, okay, and it reaches the same level here. So if I decrease the decibels, okay, here is another point, but it's still at the same level. Now I'm going down back. Here should be some, maybe this one, okay, also reaches, and the fourth should be at the end here. Okay, so when you search for defects, you can search for them according to this line and these lines, and here is the start, and here maybe it's better here. It starts here, okay, here, then it goes up, and then it disappears, okay, like this here, and then the second one is like this. Oppa, goes up and goes down. So okay, but it also increases the noise and things like that. So but it can be better, it can be worse to check, but it's on the same line and it's not very hard to see when you look at the screen and it's somewhere there. because it's very low and very small. So that's what TCG graph does. You can use it, you can not use it, which way you want. So now the last part to save this. Last time when I saved the settings, they were only 70-degree probe calibration settings, but not DAC TCG settings. So what I have created this graph, I will switch it back to DAC like this, and I can increase a bit so I can see the end. Maybe we should switch also the thickness. Okay, the thickness of this block is 50. So I will go to the big menu and then I will go to thickness. I will make it 50. Not 25. You need to get used to that. And we'll check. The view should change. And maybe we will need to change the range so we can see 3 legs or whatever. Okay, let's go back here. So I will increase the range now, not like this here. What I have done is put in the thickness of the metal there in the big menu, and the thickness of the metal 50 is like here, and here is 100. Okay, so what I have done, you can see that here the first spike is here in the beginning, then I'm going back and it's the second. Now here is the third one, here is the fourth one. Yeah? The fourth one is near the bottom here, so here is near the bottom, okay, because this one is the bottom. So that's 50, and if I go, I don't have, the block is not long enough to get the second leg, but here if I go to this place and I find something there, it means that it's at the bottom of the block there. Okay, so this spike means that there is something there. Okay, how I can check it is maybe turn around the block, there are no holes, and I want to find this corner. So what I will do is I will move it here. We don't have any defects, okay, nothing, but in here at the bottom you can see the spike. Let's decrease the range, okay, here the bottom here. So here is the maximum amplitude, and our defect line you can see is where here, so it goes even down there, and it's like there. The corner reflects all the sound from here back to the probe, so it's the spike is very high. The spike is very high because the defect is very high. That's 90-degree angle in the middle of the metal. It reflects everything back. So you can see that here the defect is very big. Yeah? But the place of it is at here. The thickness exactly at the corner. Okay? And if I move the gate, let's try move the gate. Come on, gate. to there, to the right, so we can get the spike. We will see where it is. Okay, here. Now let's increase, so we have it here. Okay, and what it shows here in the middle, the thickness of the metal is 4990. Yeah, the thickness of the metal is 50, so it's exactly down there here. So that's this one should be the distance from the start of the probe to the end. So 117. Let's check. 117 is like here. Okay, here you go. From the start to the corner here. And that one, 140, should be from that one to something 12. So it's here. Here you go. It's here. Yeah? You cannot see well, but you should trust me because it's like 140 here. Okay, it's in the middle of the probe. Yeah, so these numbers show you the place of the defect, this defect, and this defect is the corner. Okay, so you move the gate and you can see that. Okay, that's the way you. And the thickness measurement is important because you know where the bottom is with this color of the legs. Okay, now I'm going to save it because it's 46 minutes already. Okay, we need to save this DAC TCG settings. I'm going to the big menu. I'm going to files. Up. Now I want to save it. Come on, enter. Store dataset. Okay, now I need to. What was the name? Okay, I will write it once again. Okay, enter. Up there. Now maybe I can find. Okay, it was RG70, this one, and then I need to put in DAC. So 70, number, and DAC. I will make it new, enter, then I will find up RG, then let's make it the same as that one, last one. So like this. Now 70. Now one more dash. Now 383. I'm tired and you should be too. Okay, and then I need to put in DAC. So this setting, I will know that if I put it on, letters are up. Okay, enter, store, enter. Stored. Okay, let's test it. Now I want to, action will be recall, enter. I will find this one, enter, enter. Okay, it gave me this frozen, unfreeze, and now here, if I find the corner, it's somewhere here. And why? Because the thickness is not set correctly. Okay, now I go back to the main big menu. I recall another one with a DAC, enter. And now I have to unfreeze it, and now I have a graph with the dark lines here, and I can not find the holes because there are no holes there, but I can find the holes in this direction. Here are all the holes, okay, and in that direction there are no holes except this corner. Okay, let's turn this to me. That's it for 70-degree probe calibration. That was the first one. Here was the DAC and TCG graphs of the 70-degree probe. Now what I will be doing is 60-degree, 45-degree, so I won't explain everything, so it will be faster. Then I'll do transfer correction because it's already going to we are going to work. And then we'll do testing of the metal pieces that we have here. Thank you for your attention and for sticking with me. Okay, see you later.